Okay, everyone, we'll be discussing about yarn in this topic. So, yarn is basically a very small topic in a textbook, like covered within 4 pages, and almost 2 pages are only diagrams. So, you don't have to worry much about it. Whatever is required about yarn, I have written on the board and I will be explaining about it. So what is yarn? Yarn basically, it is yet another resource negotiator in Hadoop 2.0. So there were versions of Hadoop at 1.0. It was limited to only MapReduce, and MapReduce are kind of complex and there are some problems. Okay, so you can see I have listed them. I'll be discussing about them. So that's why we introduced Hadoop 2.0, which has yarn. So it is a resource management layer, and what actually it is it's a general processing platform which allows multiple applications to run within the same Hadoop cluster. Okay, so that's the basic definition of Hadoop yarn. So what are the problems with Hadoop 1.2? Single name node bottleneck. So only one name node handles all the things, like name node nothing but like slave. Okay, so which handles all the tasks and all execution and all. So only one name node to do all that. It's very bottleneck type. Only batch processing limited to MapReduce functions. Poor resource utilization. In MapReduce, what happens? First you have to do mapping. It's a mapping phase. Then only it can be sent to reduce phase. So sometimes what happens? Reduce phase, all the slots will be empty, but that mapping it will be all full. So poor resource utilization. Name node memory limit. So it has a limit about the resource or the data it can store or handle. So at a time everything cannot be given like that. Then no failover. So if one name node fails, the entire system falls apart because you don't have any backup type of thing. So that's the problem in the 1.2 system. That's why we introduced this 2.2 improvements, in which each name node manages its own namespace. So we have multiple name nodes now. So instead of one, we have multiple, in which it will be managing its own namespace. Namespace is nothing but entire database type of thing. Okay, so whatever the documents or input is, it will within the one particular database, that you can understand. Name nodes are independent, so like it's not dependent on each other. So one name doesn't depend on other name node. Okay, so they have their own self people, like they can live on their own. Like you can understand that different people from different families, they can to like take care of their own family, like that. Data nodes is shared by all name node. It's like um, student and teachers type of thing. So different teachers, but they all interact with the same students. So here all the students are being shared for the for all the teachers. So like that. So for every name node can access all the data nodes, and each data node is registered by all name node. Register in the sense it's like presence. You're putting an attendance of the data node, what and all are present, so they will be registered. Whenever you use particular data node, that will be registered in the name node for status updates. Then we have the architecture of yarn. So three components, that is resource manager, then second we have application master, and then we have node manager. So in resource manager we have two things, that is scheduler and application manager. Okay, so what scheduler does, basically it's only pure scheduling, distributing the task, who should do what and all, that scheduling it does. And what is that? Application manager is nothing but it takes the jobs as the input and activates the application master. So now what application master does, it's a negotiator. In the name is a resource negotiator. It negotiates for resources, and then to execute that particular data or resources, it requests for containers and all, and it will be interactive with name. So they both will work together and execute the task. So container is something like if you want to work on something, you need a private space. So it's the actual location where you will be working. So container can be like 4 GB RAM, 6 GB RAM, different RAM, but with different CPUs. Like one might have one CPU, one might have 6 CPUs. Node manager, what it does, it deals along with what to say, app master. It runs it checks on container, keeps an update on container, what is happening, like tracking type of thing, and it will be updating to resource manager. And at the end it executes the codes and all, final codes. So that's all the architecture about what to say this. So you can see that in chapter 5.11 that was the same thing. I did not erase anything, only the headings was erased, this. So here we had the map reduce and to task tracker, job tracker, but here few things have changed. So what you have to do, container will be pointing to application master. See all the containers to application master, and all the application master. So application master is reporting to resource manager, dotted line, even along with name. So they will be updating the status. And then one app master is directly dealing with client. So this we'll see here, we'll understand. So what is happening in this actual architecture? What is happening? First, the client will send the job or whatever it is. It will request the resource manager. So it will be resource manager will take the job in as an input from the client. Then what resource manager does? Resource manager activates a container for application master. So within a container now I have placed application master. Now what is application master does? It requests for resources. So from resource manager. So it requires I want this and this resources to work on it. So it will request from resource manager. It will give it. Then application master what does it negotiates for container. Negotiation because a container will be of different size, right? One might be a different RAM or different CPU processor. It will be negotiating. Once the negotiation is done, resource manager allocate a container to the node manager. So now the node manager has actually got the container. Now what will happen? The resource manager will access this container with the help of via node manager to do the task execution and all. Then what happened? The client can directly contact or be in touch with application master to see the status, what and all status are being updated, like whether it's pending, processing, uploading, etc. For status. And at the end, see here the application master registers for it. We saw right, it registers for a data node. So here the requesting registering is happening. At the end, it will deregister and shut down. So the process is over. Then at the end, we have key features of YARN, that is multiple framework, better resource utilization. So multiple framework is something, but it overcomes the map reduce problem. So multiple frameworks and all it is there. You can just understand. You can just look into my notes. One line is more than enough. Scalability, addition of node manager wherever required, flexibility, dealing with all sorts of things. General purpose platform. So here also we saw general purpose platform is it's available for everyone to use and free of cost and very good for utilization. So that's all about YARN. Small thing. So this completes almost 70 to 80% of the module 2, and the only thing left is chapter 8, which is actually very small, and I don't know it requires explanation or not. But anyways, I'll explain that in a small manner, because it's just 8 points, 8 topics, and each 8 topics are very like subtopic type of small things. So we'll see in the next video.